Twitter spent millions of dollars and 3 painful years rebuilding their entire architecture because they ignored one single concept.
What is that?
Today, we are breaking down that exact pillar, scalability. From taking a simple app on your laptop to building a global network that handles millions of users without crashing. Let's look at how systems actually grow. Hi folks, welcome back to our system design series. In our intro video, we talked about why layout and architecture matter at a global scale. Today, we are officially kicking off phase 1, lesson 1 with the most important foundational pillar of engineering, scalability. We are going to look at the 5 ways systems grow, the 3 core scaling strategies, and map out the exact technical journey of taking an application from zero to millions of active users. Let us start with a brutal history lesson from early tech. Twitter went down again. If you used the internet between 2007 and 2009, you definitely remember this phrase. Every single time a major celebrity tweeted or a world event occurred, Twitter used to go down and users were greeted by a famous cartoon, whale being lifted into the sky by tiny birds, affectionately known as fail whale. Why did this happen? Because in its early days, Twitter ran entirely on a single massive monolithic server. Every single viral tweet and trending topic globally slammed into one solitary machine. No load balancing, no horizontal scaling. Just one machine trying to handle the entire internet. It took Twitter's engineering team 3 painful high-stress years to completely rip apart and rebuild their architecture with load balancers, caching, and microservices, at a cost of millions of dollars and the trust of millions of users who left. That is the cost of ignoring scalability. And that is exactly what we are going to make sure never happens to your systems. Here is the official definition, and then I'll give you the version you will actually remember. Scalability is the ability of a system to handle a growing amount of load by adding resources to the system. Scalability is the ability of a system to handle a growing amount of load by adding resources to the system, not by magic, not by hoping the server holds up, by deliberately designing the system so it can grow. To easily visualize, imagine a tiny peaceful village called SERVERPUR with 500 residents. In my entire system design playlist, I am going to use this SERVERPUR village as an example. Imagine a small village called SERVERPUR, population 500. There is one main road, one market, one water tank. Everything works perfectly. The mayor is happy. Residents are happy. Life is good. Then the government announces SERVERPUR is becoming the new IT hub. 5 lakh people are moving in over the next 5 years. The same one road completely jammed. The one market 6-hour queues. The water tank empty by 8 am itself. The mayor now has exactly one job. Make SERVERPUR scalable. And that is the question every engineer faces when their app starts growing. Can your system handle 10 users? Yes. Can it handle 10 million? That depends entirely on the decisions you make today. A scalable system does 3 things. It handles more requests as users grow. It stores more data as content grows. And it serves users in more regions as the product expands. Before we go further, let's clear up a major interview trap. Developers constantly confuse 3 distinct terms: performance, scalability, and high availability. Let's break them down using our town of SERVERPUR. Performance is all about how fast your system runs right now at its current load. Think of SERVERPUR's main road at 6 am. There are 0 cars, so you can drive lightning fast. Example is an API response time under 200 milliseconds when only 100 users are online. Scalability means the system stays fast even as the load grows. If SERVERPUR's road still flows smoothly at 5 pm during rush hour because we added extra lanes, that road is scalable. High availability means your system stays functional and online even if some components completely break. If a bridge on SERVERPUR's main road collapses, but traffic instantly reroutes through a secondary highway without stopping, your city is highly available. Here is the key insight. You can have all 3, 2 or none. A system can be fast but not scalable, scalable but not available. These are different problems with different solutions. In interviews and in production, you need to think about all three separately. Systems don't grow in just one way. They grow in 5 completely different dimensions. And each one creates different bottlenecks. Dimension 1. User base. More people using your app means more requests per second hitting your servers. For example, Instagram went from 1 million to 100 million users in 18 months. Features. You launch payments, you add video, you build notifications. Each new feature is a new service, new team, new infrastructure. Data volume. Every user action creates data. Every message sent, every photo uploaded, every search query, it all gets stored somewhere. YouTube stores 500 hours of video every minute. Complexity. What started as one simple app becomes 20 interconnected services with teams working in parallel. Geographic reach. Your users are now in 10 countries. A server in Mumbai can't respond fast enough for someone in New York. Each dimension needs a different scaling strategy. Before you touch a single server, you need to understand 3 numbers. These are the 3 instruments on your dashboard. Without them, you are flying blind. Throughput. How many requests can your system handle per second? This is SERVERPUR's load capacity. How many cars can pass through the main junction per minute? Instagram handles over 1 lakh requests per second at peak traffic. That's their throughput target. Higher is always better. Latency. How long does one request take from moment a user clicks to the moment data comes back? This is how long it takes one car to travel from one end of SERVERPUR to the other. Google's target is under 200 milliseconds. WhatsApp under 1 second. Every millisecond matters. 100 milliseconds added latency can reduce conversions by 1%. Lower latency is always better. Response time. This includes latency plus any time spent waiting in queue before processing even begins. The difference. Latency is the drive time. Response time is the drive time plus time you spent waiting at the traffic signal before you could even move. Lower is always better. Now there is a trap that catches engineers off guard. As you scale horizontally, add more servers, your throughput goes up. Great. But if you are not careful, latency also goes up. More servers talking to each other means more network hops, more coordination, more delay. A request that used to hit one server now bounces between 3 services before responding. Good scaling means higher throughput without increasing latency. That's the engineering challenge, and that's what we will see in action when we talk about load balancers and caching in future videos. We have reached the end of this chapter, but our scalability journey is just getting started. Now that we have set the foundation, it is time to build on it. In the next video, we are diving deep into the code mechanics, vertical, horizontal, and auto scaling. Plus, we will map out the exact evolution of an app scaling from 1 user to 1 million. Thank you so much for watching, and I will see you in the next one.